So what we're going to focus on is stating conditions for our theorems that we use in AP Calculus. So the two theorems that we're going to kind of focus on are, or three theorems are the mean value theorem, okay, which means that the condition we need is smooth and continuous, okay, or differentiable. Because if it's the mean value theorem states that the average slope, so that line there, the average slope there exists in this interval if this red curve is smooth and continuous. So there's one example where it occurs. There's another one over here. We'd have another tangent slope that's equivalent to that average slope value here. Okay, where it doesn't work is if it is not smooth, it doesn't work, right? So if I have, there's my average slope between those 2 points. Well, because it's not smooth, there's no point where it has the same slope. The intermediate value theorem only relies on continuity. Okay, so we know that some point in between the high point and low point must exist in here within the interval if this is continuous. Okay, if this is continuous, it must that point must exist somewhere. Okay, it doesn't allow us to say anything about anything going on up here or anything going on down here. Okay, but we know that within this interval, this point must exist. Okay, where this fails is if we don't have continuity. So that's why we need that condition of continuity. For L'Hopital's, it's very important that you state, and this is very important because you will lose marks if you're not stating or at least showing that you have the condition for using L'Hopital's, which is 0 over 0 or infinity over infinity, one of the indeterminate forms. Okay, so looking at some of these questions then. Okay, so f is a function that is differentiable on the closed interval 2 to 4. Okay, so what's really important is that you recognize this term, okay, differentiable, which means it's smooth and continuous, which means we can apply L'Hopital's, we can apply mean value theorem or IVT. Because it's continuous, and not only continuous, it's smooth and continuous. So I have this interval, okay, from 2 to 4, something like that, and we have 10 to 20. Okay, we know that a point exists here, and we know that a point exists here. So it says f of 13 has at least one solution on this open interval. This must be true. Okay, f equals 13 has at least one solution on this open interval. Okay, so because it is continuous, we can apply IVT here. Okay, and we can say that, yeah, that's true. f of x equals 13 somewhere in this interval, because here's 13. Okay, and no matter how we draw it, okay, 13 must exist. Okay, so that's true. B says f3 equals 15. Okay, so f of 3 is right here, right in between, and it has to equal 15. Well, that's not true because we don't know. We have no idea. That point at 3 could be way up here, it could be way down here. We don't know, so that we can eliminate that as a possibility. F attains a maximum on this open interval. Well, we don't know that it is always increasing. Okay, so we can, in this situation, we could actually draw a graph that looks like this. Okay, we can draw that looks like that, which then it does attain a maximum in that open interval. But in this case here, the way we've drawn it, it is possible that the maximum is just always increasing, and the maximum occurs right at the end point. Okay, and since it's an open interval, the end point is not included, so this is not possible. This is not necessarily true. F prime equals 5 on this open interval. Well, it is smooth and continuous. So if it is smooth and continuous, then that means that if we calculate the slope here, Okay, this is a rise of 10, run of 2. So the average slope is equal to 5. Okay, so m equals 5 on that red line. This says that f prime equals 5 has at least one solution on the open interval. That's true because it is differentiable, we can apply MVT. A mean value theorem says, yeah, there is some point, we don't know where, but there is some point, at least one, that exists in between 2 and 4, where the tangent slope, or f prime, is equal to the average slope, which is, the average slope was calculated to be 5. So this is true. Okay. For e, f prime of x is greater than 0 for all of x in the open interval. We don't necessarily know this is the case. In fact, the way we've drawn it, notice that it does go down. Okay, so f prime is not always going to be positive in that open interval. So we're going to have to eliminate. So the possibilities are A and D. Okay, because due to IVT, we can say A is A is true, and for MVT, we can say that D is true.